Hi, this is Doc Revis here. This is a quick and dirty, non-polished video on assigning charges for ionic compounds that have polyatomics. It's a quick and dirty video that I made for my Chem 111 students at Saginaw Valley State University. So here it is. I have a table on the right side that you can take a look at, and that table has the polyatomics in it. And these are the most common polyatomics that you see in freshman chem and Chem 111 at Saginaw Valley. So when you name these polyatomics, the names are there. That's exactly what they are. So you name the first part of the compound, the second part. For example, sodium hydroxide. You get it? Sodium nitrate, lithium nitrite, potassium chlorate. So you don't tell how many anything. You just simply name them. You name the first part followed by the second part. The first part is always the positive side of the compound. So anytime you see a compound written, the first part is the positive side. Don't second guess that. It is the positive side. So here it is. Let's do a couple of these to show you how to make compounds. So if you have lithium plus 1 and nitrate minus 1, nitrate's the polyatomic, you crisscross and you get lithium nitrate. You don't need parentheses because the atoms have the same charges. So you get what you get when you have the same magnitude or same size charges. Just simply, basically, erase them, and you get the right compound. So let's do another one with barium plus 2 and nitrate minus 1. In this case, we need to bracket the nitrate. Remember, nitrate is not N and O and 3, it's NO3. You get it? So you don't say NO3, it's NO3. That's how we actually say it. You get it? So you have to see that as one thing. So when you have a value larger than 1 that's going to be on the outside of parentheses, you have to give it, if you have a value larger than 1, you have to put it outside the parentheses. You get it? So that's why you see it like this. You need the parentheses then. So now you're back to magnesium plus 2 and carbonate. All right, the carbonate's minus 2. That's the standard. So we crisscross. We get same size charges in terms of the magnitude, but one's plus and one's minus. The first part is always plus. The second part is minus. We get magnesium carbonate. Now notice I'm naming them just like that. That's it. That's straightforward from knowing the polyatomic anion portion of the compound. Okay, so now let's move on to aluminum carbonate as well. Carbonate has a minus 2. Aluminum has a plus 3. Since aluminum's the first part is always positive, that's how it is. So here you put the 2 outside the aluminum and the 3 from the aluminum that's shared when you crisscross outside the carbonate. So don't multiply that 3 times 3. That's not 9 because carbonate is CO3. It's one thing. Always think of the polyatomics as being one thing, not two things. And that helps. And that's when you put the parentheses. Now this is important. Always remember, the first part of the compound is always positive. There are some exceptions. But for now, in this quick and dirty video, just to tell you the story, that's it. Okay, you got it? Now, let me show you what to do if you want to assign the charges. When you assign charges, do not start with the positive side. In general, for Gen Chem 111 or freshman chemistry, start with the negative side. The negative tends to be the standard or what sets the assignment of the charges. So basically, in the case here, we have sodium phosphate. And again, because it's an ionic compound of salt, you simply just name it. Sodium phosphate. Don't try to tell how many. It doesn't matter when it comes to ionic compounds. Okay? You just say it. Sodium phosphate. Now, the PO4 is a standard. So I look on the table or I have it memorized, and PO4 is a standard at minus 3. So we know it's a minus 3. That's how I start. That's the first thing I do is assign the negative side of it. Okay? Then you do the math to figure out what goes on the positive side. But keep in mind again, PO4 is not P and O. It's PO4. So no, do not separate them. Do not do any math between them when you're assigning charges. Okay? There's no multiplication of the 4 there. Okay? Because PO4 is a single unit, not a separate one. PO4 is the same as putting it PO4 in brackets with the charge outside the bracket. So we assign here the PO4 to a -3, and so we just rewrote it here again. And now we note that if we do the math on both sides, we have a -3 charge on the right, and therefore we must have a +3 on the left. Because we're not looking at the 4, do not look at that 4 in PO4. You got it? So sodium then must be a +1 so we can have electronic neutrality. I show you that by showing you sodium sodium phosphate. You do the charges, it's all neutral. Then we show you a few other examples. H2SO4. SO4. It's not S and O4, it's SO4. You get it? So SO4 is a -2. So the negative side, I assign the SO4 because that's the standard. Do not work from the positive side. Don't make that mistake when it comes to transition elements. People will have a tendency to put the positive side on first when they see the transition element because they look on the periodic table. Go to the minus side first. So I assign the minus side to -2 because that's my standard. I looked on the table or I memorized it. SO4 is -2, so the negative side is -2. So I need a +2 to balance this off. So that means hydrogen must be +1. Take a look at boron sulfate. So we have boron here, and we note that sulfates are -2. So we put the -2. 3 times -2 gives me -6. So I have 2 borons, so I must need a +3 to have a +6. It's balanced. Calcium hydroxide, we put the parentheses around it when we wrote it, or we looked it up, we Googled it, we have it. But OH is hydroxide, not O and H. So OH is -1. Not O and H, but OH is -1. So I have a 2 outside OH, gives me a -2 on the negative side. That means I only have 1 calcium, therefore that means I have a +2, and voila, we get it, +2 there. Then we have, what did I write? Potassium nitrate. So you have potassium nitrate, -1 because I looked it up or I memorized it, and the negative side is minus because I always start on the negative side. And then I assign the positive so I can get electronic neutrality, and there you have it. That's how we do these. Now, in terms of name them, again, you simply name them and say the polyatomic. Do not change the name of the polyatomic. It is exactly what it is. So therefore, all you need to do is name the first part and the polyatomic, and you got it. So, to recap, when we crisscross the charges, we don't need parentheses if the charges are the same, but if the charges are not the same, you might need a parenthesis. Okay? When we assign the charges, we always start, absolutely always start, no matter the day of the week, you always start with the negative side, look at the chart, figure out what it is, assign it, then do the basic simple math to get the positive side. Do not arbitrarily assign the positive by looking at the periodic table. Let me repeat, do not look at the periodic table to assign the positive side. Start with the negative as the standard. There you have it. Doc Revis, quick and dirty look at how to do charges for polyatomics.